Now, we have discussed gases throughout our previous lessons. We've stated that some elements exist in nature as diatomic gases, and these are such examples as hydrogen gas, nitrogen gas, oxygen gas, fluorine gas, and chlorine gas. There are also some elements that exist in nature as monoatomic gases, mono meaning one. And this example is going to be group 8 on our periodic table, and that would be all of the noble gases. We also discussed how gases do not experience any intermolecular forces because the atoms and the molecules are too far apart and do not touch each other to have any sort of interactive forces between them. They're also moving at a faster pace than the solid or a liquid, so they also can't have any sort of intermolecular force. Now that we've learned about more molecules, how to name the molecules, how they react in different circumstances, we can define a few more molecules that exist in nature as gases. So HCl, or hydrogen chloride or hydrochloric acid, this exists at room temperature as a gas. We also have ammonia, NH3, that exists as a gas, carbon dioxide, which is all around us in the air that we breathe and breathe out. We have dinitrogen monoxide or nitrous oxide, which is what they use at the dentist. Laughing gas is nitrous oxide. We have methane gas, which is a type of natural gas, and hydrogen cyanide is also a gas. Gases are very different from solids and liquids in many ways. First, a sample of gas assumes both the shape and the volume of the container that it's in. Gases are compressible, unlike solids and liquids. The densities of gases are much smaller than those of liquids and solids and are highly variable depending on the temperature and the pressure that the gas is at. Gases will form homogeneous mixtures, also known as solutions, with one another, so two gases can form a mixture, in any proportion. Okay, we can have as many gas particles in any proportion with another gas particle as we can. Finally, since we're going to be talking about gases, we need to define a new unit that we haven't worked with in the past. So gases utilize the unit of pressure. Pressure is defined as the force exerted on a given area. So pressure, P, is equal to force, F, divided by the area, A. The SI unit of force is the Newton, which we denote with the variable capital N, where 1 Newton is equal to 1 kilogram times meters per second squared. The SI unit for pressure is the Pascal, which we have a variable for as PA. And this is defined as 1 Newton per square meter. So 1 PA, 1 Pascal, is equal to 1 N over M squared. Since we're really going to be working with the unit of pressure, the Pascal, we have other units of pressure that we can utilize so that we don't need to use the Newton expression. So we have many different units of pressure that we can use when we're talking about gases. Many of these you may have heard before. First, we have standard atmosphere pressure, or ATM. That's the unit for standard atmosphere pressure, ATM. And this is the pressure at sea level. Whenever we're talking about pressure around us, we are always referring to atmospheres, ATM. That's the pressure that we experience every day. We can relate the ATM or the atmosphere to our base unit or our SI unit of pascals using our definition of 1 atm. 1 atm is equivalent to 101,325 pascals. This is now a conversion factor if we ever wanted to convert between pascals and atmospheres in terms of pressure units. A second pressure unit that we have is the millimeter of mercury. And this is a specific pressure unit for reading a barometer, which is how we read pressure. So it's a barometer measurement. We can also have an equivalency to millimeters of mercury using our equivalency to pascals. 1 millimeter of mercury is equal to 133.322 pascals. Once mercury was discovered to be harmful to ourselves and others around us, they decided to move away from using millimeters of mercury as a way to measure pressure. So they turned that unit into the unit of torr. And this is just the name given to millimeters of mercury in honor of Torricelli, who is the inventor of the barometer. Okay, and they moved away from using mercury once they switched to torr. They used a different compound to measure their pressures that still gave the correct values as millimeters of mercury, but wasn't as harmful as mercury itself. So 1 torr is also equal to 133.322 pascals. Our other pressure unit that we have is the bar. And the bar is just a different pressure unit that has the same order of magnitude as ATMs. Okay, so it's still a large value, but it's a decimal multiple of pascals. So we see that pascals, if we were to simplify it into scientific notation, can go to 1, 2, 3, 4, 5. You would get 1.0 times 10 to the 5th pascals. And that's what a bar is telling us. It's just a way to simplify pascals to be a more understandable number. You'll get things that are more like 1 bar or 3.5 bar, which is a lot easier to understand and comprehend in terms of how pressure is changing than if we were to say the pressure changed from 101,325 pascals to 102,478 pascals. So it takes a lot longer when the number is larger to understand what that difference means, so the bar just simplifies it for us. When you want to do these pressure conversions on your homework or your exams, in ALEKS, a conversion chart can be found in the Conversion Factors for Non-SI Units chart in the Data tab on ALEKS. And I believe in some of my future slides when we practice doing these conversions, I have the ALEKS table present so that we can get used to those conversions because they are not the exact same conversions as we see here. They are related to the ATM instead of to the Pascal. The conversions will still work out whether you use this table or the ALEKS table. Okay, they're all the same conversions, they're just in terms of a different pressure unit. Which we'll see as we go on. Okay, but because that ALEKS table is the one that you have in front of you during your exams, you're not going to have this table in front of you here. Because that ALEKS table is the one that you are going to have, we're going to practice with it as well so you get used to it for your homework and your exams. So we can use all of these different equivalencies for pressure to convert between any two pressure units. So we have our table here of our pressure units, and specifically what we're going to be using is their definitions, their equivalencies to the Pascal. And we're going to use them to convert between 742 torr to PA, to pascals, as well as to ATMs. So we're going to start these problems off similar to how we do any conversion. We're going to start with the number that we're given in the problem, 742 torr. And we're going to set up our equivalency to show how our units cancel so we know if we need to multiply or divide by our conversion factor. So if we go to torr, we know that 1 torr is equal to 133.322 pascals. Well, I want to convert from torr to pascals, so torr should go on the bottom, and pascals should go on the top. That way we can see that torr will end up canceling. So now we just have to put numbers to that. We know that 1 torr is equal to 133.322 pascals. So let's get our calculators out. We're going to take 742 and multiply it by 133.322. That's going to give us a pressure unit of 98,924.924 pascals. Now we have to simplify this to be in 3 significant figures, so we would get 9.89 times 10 to the 4 pascals. And that's how we convert from torr to pascals. We now want to go from 742 torr to ATM. Well, currently the only conversion I have for ATM is 1 ATM is equal to 101,325 pascals. So since I already have a value for 742 torr in terms of pascals, I can just use that number to convert to ATMs, because this number here is equal to that number there, just in different units. So we're going to start with 9.89 times 10 to the 4 pascals. And we're going to set up our conversion factor so that pascals are on the bottom to cancel out. And ATM is at the top so that we're left with units in ATM. So 1 ATM is equal to 101,325 pascals. So we'll take that 98,924. We will divide it by 101,325. Again, if you're using a calculator, you can just hit the division button and use that same number. If you wanted to rewrite it as 9.89 times 10 to the 4, you can also do that as well. You'll get the same number out. It may be slightly different due to rounding, but the number when it comes out in sig figs will be the same. So we get a value of 0.976 ATM with 3 significant figures. Let's keep practicing these conversions just so that we can master them. Here is your ALEX table. So this is what you're given on ALEX for your conversions for pressure. So again, it relates everything to 1 ATM instead of 1 pascal, or to the pascal unit. So they look a little bit different, but they do the same thing. They do the same conversions. So this is what you're going to be given on your homework and your exams for you to use to convert. So let's get used to using it and use these values to convert for these next few problems. Our first problem here doesn't require any additional conversion factor between 2 different pressure units because we're going from kilopascals to pascals. Kilo, that's one of our prefixes. So it's just like going from kilograms to grams. It's the same conversion because kilo is the prefix. So we know from our prefix that 1 kilopascal is equal to 1,000 pascals. That's the only conversion factor we would need to convert for this problem. So we're going to set up our problem to be 3.17 kilopascals. We're going to put 1 kilopascal on the bottom so that our units cancel. And we're going to put 1,000 pascals on the top to be left with units of pascals, which is where we want to be. So we take 3.17 and we're going to multiply it by 1,000. And for sig fig purposes and to not have an ambiguous 0 at the end, we're going to call this 3.17 times 10 to the 3 decimal there, pascals, right? 3,170 has an ambiguous 0 at the end of it. So to avoid that and to have proper sig figs, we're going to convert it into scientific notation. Okay. Our next problem has us converting between 3.17 kilopascals. Now we're going to ATMs, or atmospheres. So let's look at our conversion factor chart and see if we have a direct conversion between ATMs and KPAs. We do. It's our first conversion here. 1 ATM is equal to 101.325 kilopascals, which is similar to the conversion we used in our previous problem, just off by a factor of 1,000, because kilopascals and pascals are different by a factor of 1,000. So we're going to start our problem here, starting with 3.17 kPa, and we're going to set up our conversion. We know that ATM is going to be on the top so that our units are left in ATMs. And 1 ATM is equal to 101.325 kPas. By putting kPas on the bottom, they cancel out and we're left with units of ATM. So we'll take 3.17, we'll divide it by 101.325, and we get a value out of 0.0313. My threes are not showing up well today. 313 ATMs. 3 significant figures for our final answer there. Okay, our last problem now wants us to convert 615 millimeters of mercury to kilopascals. So if we look at our conversion factors that we have, all of these here are related to the ATM. So 1 ATM is equal to all of these numbers here. So while we have millimeters of mercury and kPas here, we don't have a direct conversion between those two values in the table that's given to us on our ALEKS homework and exams. So let's practice how we're going to do this type of problem using the table that we're given on our homework and exams. So the first thing that we're going to want to do is convert from millimeters of mercury to ATMs. Because if I have my units in ATMs, I can now go between any one of these pressure units. So once I have ATMs, I now have an equivalency to get to kPas. So we can go from ATM to kPas. So some of our conversions are going to be multi-step conversions, and I'm showing it this way because this is the table that you're given on your homework and exams, and it does not have that direct conversion between millimeters of mercury and kPas. While we have a similar one on the table we showed previously from your textbook, that's not given to you. So we want to make sure we can master this topic with the table that we are given. So the first step says to convert from millimeters of mercury to ATMs. So that's what we'll do. We'll take 615 millimeters of mercury. We'll put ATMs on the top and millimeters of mercury on the bottom. So 1 ATM is equal to 760 millimeters of mercury. So 1 ATM is 760 millimeters of mercury. That's an exact number, so I'll put a decimal right at the end there to show that it's exact. And we'll do that conversion. So 615 divided by 760. So we get out a value of ATM of 0.809210. And I'm going to leave a few extra decimal places because that's not my final answer. So I don't want to round for significant figures until the very end of the problem. So we've done our first step. We've converted from millimeters of mercury to ATMs. Now we want to convert from ATMs to kPas using our conversion factor. So 0.809 210 ATMs. We're going to convert that to kPAs. So we'll put kPa on top, ATM on the bottom. And our conversion factor for ATM and kPAs is right here. We'll put 1 ATM on the bottom and 101.325 kPAs on the top, right? Because 1 ATM is equal to 101.325 kPAs. So now we can do that conversion. We'll take that 0.809, we'll multiply it by 101.325, and we get out a value with 3 significant figures to be 82.0 kPAs. That 81.99, that'll round up to 82.0 for 3 significant figures. So we may have to do multi-step conversions depending on the conversion factors we have in front of us. So we did our second step and got our value in kPAs. So let's continue to practice that. The atmospheric pressure at the summit of Denali is 851 millimeters of mercury. Convert this pressure to ATMs, kPAs, and bar. So what I want you to do is pause your video and try these conversions on your own using the table from Alex, which is given here on the slide. Use this table, get used to using this table. If you have to do multiple conversions because of this table, that's fine. Please get used to that now so that you are prepared for your exam. Our first step has us using a direct conversion from millimeters of mercury to ATM. So we're going to use our last conversion factor down here. So we can say that 581 millimeters of mercury, we can set up our equivalency to have ATM on top and millimeters of mercury on the bottom. So 1 ATM has 760 millimeters of mercury, so we'll take 581, and divide it by 760. And we get out a value in ATM of 0.764 ATM with 3 significant figures. Now that we have the value of millimeters of mercury in ATM, we can now use that value to convert our second 2 values. So we can start off both of these problems with 0.764 ATMs instead of starting with 581 millimeters of mercury. Because if we started with 581 millimeters of mercury in each of these steps, we would have to convert them to ATM as our first step anyways, using this conversion chart from Alex. So we have those values right now. We know from this equivalency that 581 millimeters of mercury is 0.764 ATMs. So we can now use those to convert to kPAs and bar. So for kPa, I know that 1 ATM is equal to 101.325 kPa. So we'll take that 0.764 and we'll multiply it by 101.325. And that gets me 77.4 kPAs with 3 significant figures. For our last example with converting to bar, we'll set up our equivalency to have 1 ATM on the bottom. And for bar, that's 1.01325 bar on the top. So we'll take 0.764 and we'll multiply that by 1.01325 bar. So that gets us 0.774 bar. 3 significant figures for our final answer there. Let's do a few more. For this problem, we want to know which of the following equalities is true. There can be multiple. So what we're going to want to do for this problem is to convert from our initial units to our final units. Okay, so from ATM to torr, millimeters of mercury to PSI, using our conversion chart here. If your answer from when you do that conversion is the same that's given here in the problem, then that equivalency or that equality is then true. If they are not the same, then it is false. So what I want you to do is to pause your video and start converting from these units given to the units in the after the equal sign, and see which of these equalities is true and which ones are false. Some of these involve a one-step conversion and others involve a two-step conversion because you have to go through ATMs. So for our first one, this is only a one-step conversion because we have a direct conversion factor between ATMs and torrs in our conversion chart. So we'll start that up here. I'm going to start right at the top of my slide, just for room. So we start with 0.80 ATM. And we know that 1 ATM is equal to 760 torr. So we'll take that 0.80 and we'll multiply it by 760. And that gives us an answer of 608 torr. And we'll ignore sig figs because it's just proving if something is true or false. So that means that A is true. Next up, we'll do B, where we're converting from millimeters of mercury to PSI. PSI is a pressure unit that we didn't see earlier. That's pounds per square inch. This is typically used in tire pressure, or if we're filling up some sort of container with air, PSI is the typical pressure. So that's a new one here that we didn't see before. So we don't have a direct conversion between millimeters of mercury and PSI, so we're going to have to go through atmospheres. So we'll start with 209 millimeters of mercury. And we know that 1 ATM has 760 millimeters of mercury. That will give us, let's see, 209 divided by 760, 0.275, there we go, ATMs. Now that we have ATMs, we can use our conversion factor for PSI to convert from ATMs to PSI. So we'll start with 0.275 ATM. In 1 ATM, we have 14.696 PSI. So we'll take that 0.275, we'll multiply it by 14.696, and we get 4.04 PSI. Again, ignoring sig figs because we're just looking at if equalities are true. And based off of our answer in B, B is also true, where 209 millimeters of mercury are equal to 4.04 psis. Okay, let's do our next one. C. We're taking torr and converting them to millimeter of mercury. Now, what we discussed earlier is that torr and millimeter of mercury are the same unit. So we can also see that torr and millimeters of mercury are equal to each other. They're the same unit, they're the same conversion for anything that we're doing because they're coming from the same value. We just renamed millimeters of mercury to torr. So if we have a torr value, torr should equal millimeters of mercury, right? 1 torr is equal to 1 millimeter of mercury. So our equivalency here, we move this up here, that's our discussion for question 3, or C. 1 torr is equal to 1 millimeter of mercury. So 433 torr should equal 433 millimeters of mercury, which is not the equivalency we have here. So C would be false, and we didn't even need to do a conversion factor to do that because we know that torr and millimeter of mercury are equal to each other. You could do a conversion factor to prove that to yourself, so convert from torr to ATM and then ATM to millimeter of mercury. You can find that they would be equal to each other, and also that this statement would be false. Okay, let's move on to our last two. We have D, where we're converting from ATM to bar. Well, that's a one-step conversion because we have the equivalency here. So 575 ATM. If we're converting to bar, we're going to put 1 ATM on the bottom and 1.01325 bar on the top. So we'll take 575 and we'll multiply it by 1.01325. And we get out that this is equal to 583 bar, which is equal to our equivalency that we have above, meaning that D is also true. For our final example, we have 5.5 ATM that we want to convert to pascals. Now we have a conversion for ATM to kilopascals, and not a direct conversion between ATM and pascals. However, we know that to go from kilopascals to pascals is just a prefix conversion, which we already know how to do. So our first step is going to have us converting to kilopascals. So ATM, we're going to convert to ATM by putting convert to kilopascals by putting 1 ATM on the bottom and 101.325 kilopascals on the top. So we'll get a value out for that, 5.5 times 101.325, and we get 557.2875 kPas. Now, if I want to go from kilopascals to pascals, we're going to take 557.2875 kPa, and using our conversion of 1 kPa is equal to 1,000 pascals, PA, we can use that to solve. So 1,000 pascals would go on top and 1 kilopascal would go on the bottom. So we'll take that 557 and multiply it by 1,000. And we get out 557.287.5, which if we convert to scientific notation is 1, 2, 3, 4, 5. 5.5 times 10 to the 5.6, that should be 5.6 pascals with rounding. So our equality is true because it says that 5.5 ATMs is equal to 5.6 times 10 to the 5th pascals. So this one is also true. So 4 out of our 5 equalities were true for this problem. Now we want to talk about how we can measure this pressure. So we've converted all of our pressures, but how do we actually measure it? Well, we use pressure oftentimes if we're predicting weather. Okay, we use it in weather. You use it in a lot of engineering circumstances. We need pressure and we have to measure it somehow. So we have different measurements of pressure. First, we have a barometer, which is an instrument that is used to measure atmospheric pressure. So that's how we measure the pressure outside. We use a barometer, and that's what weathermen use to measure the pressure outside when it's changing. We want to note here that we have a standard atmospheric pressure, or what's also referred to as normal atmospheric pressure. And this is 1 atm. And this was originally defined as the pressure that would support a column of mercury that is exactly 760 millimeters high. So that's how we get 760 millimeters of mercury is equal to 1 atm. So our standard pressure, our standard atmospheric pressure, 1 atm, is equal to 760 millimeters of mercury. So that's how we get all of our equalities that we just saw in our ALEKS table. They're all related. We can also use a manometer, which is a device used to measure pressures other than atmospheric pressures. And this uses gas in a tube here. Let me zoom in. Uses gas in a tube here and mercury or some other substance other than mercury to be safer. And we can measure the difference between where the mercury starts and where the mercury ends, and based off of that height, we can measure the pressure of that gas in the same way a barometer can be used. This is just specific for non-atmospheric pressure. So every other pressure of a gas that we want to measure is measured through a manometer.